Hello everyone and very good evening. I hope you all are good and doing well. So today from the class we are going to start new chapter or new topic you can say. This is capacitor. This is a small portion, so a small topic but important one. So we will traverse through it in today's class. Okay? How is everybody? Before we dive into the topics, let's have some talk. Very good evening, everyone. Who is this? RN. What's your full name? Kalash. You are following all the classes. You were not in. You were in the previous class, but previous to previous, you were not there, and that is why I'm asking. Lakshmi, she is not there. Okay, Stuti is there. Should we wait for some 1 minute before we start? But it has already been 5:02, right? So, good afternoon, Kiran. Yeah, you are here. That's great. चलो ठीक है, वी विल बी स्टार्टिंग विद द टॉपिक. कैपेसिटर बहुत ही इंटरेस्टिंग टॉपिक होने वाला है, easily understandable and interesting. So in this lecture, today's lecture, we will be learning basically capacitor होता क्या है, what is capacitance, and then we will see combination of capacitors, just like in class 10 you all must have studied combination of resistors. ठीक है, तो चलो डाइव करते हैं. कैपेसिटर होता क्या है? So basically capacitor is a system of two conductors. So uh, when we try to make a capacitor, we keep two conductors separated by an insulator. ठीक है, so maybe we are using two plain sheets. ठीक है, so we have two sheets like this. देखो मेरी डायग्राम ना बहुत खराब है, सीरियसली. So let's say we have two such sort of plates. दिख रहा है ना तुम्हें? So these are two parallel plates. Let's say this is conductor. This is also conductor. And we have kept two conductors here. And we are separating these two conductors by insulator. I mean, let's say we are keeping two conducting plates like this. And a space between these two plates is getting occupied by air और वैक्यूम. एयर इज वॉट? इंसुलेटर. अगर यहाँ पे एयर है तो ये भी ये क्या है? इंसुलेटर है. इंसुलेटर को हम एक और टर्म से बुलाते हैं इन फिजिक्स, दैट इज कॉल्ड योर डायलेक्ट्रिक. सो डायलेक्ट्रिक मीनिंग व्हाट वी आर टॉकिंग अबाउट? इंसुलेटर. डन है. सो इज इट लाइक capacitor is constituted by what? Two conductors separated by an insulator. Now, what is the function of this capacitor? Why in the first place we are keeping two conductors separated by insulator? So simple target is that we want to store electrostatic energy. We want to store charges. Okay? So here in the system, what we will do, we will give one plate positive charge. Okay? And when we are giving one plate positive charge, since this is a conductor, charge, I mean, this is a conductor, and this in front is also a conductor. If you are giving the first plate positive charge, because of this seat, there will be electric field outwardly directed like this. And this electric field will do what? जैसे यहाँ पे देखो एक प्लस चार्ज हमने रख दिया and there is conductor in front. What will happen? This what positive charge will do here? It will attract the free negative charge on the front surface of this seat, right? And on the back surface, positive charge will go. So अगर आपने कोई भी एक प्लेट को, एनी वन प्लेट को अगर आपने कुछ भी पॉजिटिव चार्ज दिया, सेकेंड प्लेट के फेसिंग सरफेस के पास कौन से चार्ज जाएंगे? नेगेटिव चार्ज विल गो. ठीक है. एंड capacitor look like we have two plates, one given positive charge and another given negative charge. So basically we don't give negative charge to another, or we don't give both the charges to the plates. only on one plate we give charge and on another plate charge get induced. ठीक है. So यहाँ पे अगर आपने पॉजिटिव चार्ज दिया एक प्लेट को प्लस क्यू, then negative on another plate minus q charge will get induced. Also on this side plus q charge will get induced क्योंकि this plate was electrically neutral, right? But in system of capacitor, we only want a negative charge on the inner surface. तो इस चार्ज को अगर मुझे हटाना है तो इसको हम अर्थ से कनेक्ट कर देते हैं. And when we will connect to earth, this positive charge will travel to the earth. This negative charge won't travel to the earth because that is bonded by this layer of positive charge on the plate in front. ठीक है. So इस प्लेट के पॉजिटिव चार्ज की वजह से this negative charge will stay bonded through electric field and this positive charge will flow to the earth, and this way we will get one plate having positive charge and another plate having negative. ठीक है. सो बेसिकली कैपेसिटर क्या है? कैपेसिटर इज अ सिस्टम ऑफ टू कंडक्टर सेपरेटेड बाय एन इंसुलेटर. तो सबसे पहली चीज ये है कि इन दोनों कंडक्टर्स के बीच का जो स्पेस है, दैट स्पेस शुड बी इंसुलेटिंग, इट शुड बी डायलेक्ट्रिक, इट शुड नॉट बी कंडक्टर. क्योंकि अगर कंडक्टिंग स्पेस हो गया ना, अगर आप देखो यहाँ से कंडक्टिंग स्पेस है तो क्या होगा? पॉजिटिव चार्ज नेगेटिव चार्ज की तरफ चल के चला जाएगा. ठीक है. एंड देन everything will get neutral. Done it. So if we want to keep our charge stored, we need to have here the media which is insulator, and that is why we keep here dielectric. Done it. Now the question is these plates always like seat? No, it can be circle, it can be spherical like this also, it can be cylindrical also, two cylinders, coaxial cylinders, one having positive charge and another having negative charge. So it can be of any shape. In fact, it can be a single conductor also. क्योंकि हमने डेफिनेशन में लिखा टू कंडक्टर मे बी. जैसे यहाँ पे देखो स्फेरिकल कंडक्टर की मैं बात करती हूँ. सो वन स्फेरिकल कंडक्टर आई टुक ऑफ रेडियस आर, मे बी अनदर आई एम टेकिंग ऑफ रेडियस आर इक्वल टू इंफिनिटी. मतलब मैं ये कहना चाह रही हूँ कि व्हेन वी टॉक अबाउट सिंगल कैपेसिटर, that I mean when we talk about single conductor, that is also a capacitor. In that case another plate is at infinity. That is what I wanted to say. क्योंकि सिंगल कंडक्टर भी है, उस पे भी हम चार्ज स्टोर कर सकते हैं. So whatever can store charge is called capacitor. Only requirement is in the media or in the surroundings should be insulator. So it can look like a single conductor also, and in that case we will assume that another conductor is at infinity. क्योंकि यहाँ से जो भी इलेक्ट्रिक फील्ड जाएगा दैट विल एंड एट इंफिनिटी. इफ यू आर गिविंग इट पॉजिटिव चार्ज, then its electric field will end at infinity. Then we will say another plate is on the infinity. क्योंकि parallel plate में देखो यहाँ से electric field positive से release हो रहा है and it will end on the negative plate. So coming from one plate ending on the negative plate. Here if we say this is a capacitor, then electric field is coming out from this plate, end on infinity. It means on infinity we will assume there is another plate. ठीक है. चलो, now we will define capacitance. Capacitance is what we know now. What is capacitor? What is its function? So basically capacity of capacitor gets defined by the term capacitance. ठीक है. So capacitance basically identify what is the capacity of conductor. Done it. So this is capacity of conductor to collect and store energy in the form of electrical charge. Let me tell you here only capacity. Yes. Any doubt? No, then I am muting everybody. Yeah. Sorry. चलो ठीक है. अभी you can talk. Let me know.
Difference between capacitor and capacitance.
Sorry, you're not audible. Be a bit louder.
Madam, difference between capacitor and capacitance.
Capacitor and capacitance में difference पूछ रहे हो?
Yes, madam.
Okay. So capacitor basically अगर मैं ऐसे बताऊं तो कैपेसिटर बेसिकली नाउन हुआ एंड कैपेसिटेंस इज वर्ब एंड नॉट वर्ब इट्स फंक्शन. तो कैपेसिटर का मतलब क्या हुआ? कैपेसिटर का मतलब वेयर दिस इज अ डिवाइस. कैपेसिटर इज बेसिकली अ डिवाइस एंड इस डिवाइस का काम क्या है? इसका फंक्शन है टू स्टोर चार्ज एंड कैपेसिटी टू स्टोर चार्ज इज कॉल्ड कैपेसिटी. ठीक है. सो you cannot store infinite amount of charge on this sphere. There will be certain limit to the charge. In the next slide I will discuss why will be limit, but yes, there will be limit. So every capacitor, every conductor has certain capacity of storing charge, and that capacity is getting defined by capacitance. Is it clear?
Okay, madam.
ठीक है, चलो. कोई डाउट है और किसी को तो बताओ. एनीवन? Nobody? चलो ठीक है. So now I will discuss capacitance has a limit. Yes, it has a limit. Answer will be yes. But why there is limit on the capacitance? चलो मैं एक काम करती हूँ. Let's talk about दिस पैरेलल प्लेट कैपेसिटी. इस पे मैंने पॉजिटिव चार्ज डाला. देखो, पैरेलल प्लेट को मैं एक लाइन से ड्रॉ कर रही हूँ क्योंकि बार बार ऐसे ड्रॉ करने में इट विल टेक more amount of time, energy, everything. So basically plate is like this, but everywhere in the diagram you will see like this. It doesn't mean it's a line. It is still a plate. ठीक है. So plate को हम ऐसे दिखाएंगे and then there is another plate here. ठीक है. एंड इस प्लेट पे कौन से चार्ज है? नेगेटिव चार्ज. डन है. नाउ इफ देर इज such sort of thing, what will happen here? In the space between the plates there is air. Let's say there is air. और इस स्पेस में इलेक्ट्रिक फील्ड भी होगा. ऐसे इलेक्ट्रिक फील्ड होगा ना. किनारे जो कैपेसिटर का जो एंड्स होंगे वहां पे इलेक्ट्रिक फील्ड थोड़ा स्ट्रेट लाइन से कर्व्ड होगा. तुम लोग जानते हो फ्रिंज इफेक्ट. आई हैव ऑलरेडी डिस्कस्ड इन द क्लासरूम क्यों होता है. सो मिडिल में इलेक्ट्रिक फील्ड तुम्हें कैसा दिखेगा? स्ट्रेट लाइन. कॉर्नर वाले कर्व्ड हो सकते हैं. दैट इज कॉल्ड फ्रिंज इफेक्ट. ठीक है. दैट वी हैव डिस्कस्ड इन इलेक्ट्रोस्टैटिक्स. तो बिकॉज ऑफ दिस इलेक्ट्रिक फील्ड इन द रीजन व्हाट विल हैपन? देखो, जैसे जैसे हम इस प्लेट पे पॉजिटिव चार्ज बढ़ता जाएगा, यानी कि इस पे नेगेटिव चार्ज बढ़ता जाएगा, वैल्यू ऑफ इलेक्ट्रिक फील्ड इन द रीजन विल इंक्रीज because then more number of field lines will come out from the positive plate and end on the negative plate. Done it? So as you are increasing the charge, electric field value is getting stronger. And can we make it एज स्ट्रॉन्गर एज वी वांट? कोई भी लिमिट दे सकते हैं क्या इलेक्ट्रिक फील्ड को? कितना भी बढ़ा सकते हैं क्या? नो, वी कैन नॉट इंक्रीज इलेक्ट्रिक फील्ड टू एनी वैल्यू बिकॉज एवरी डायलेक्ट्रिक, एवरी इंसुलेटर हैज दैट हैज डायलेक्ट्रिक स्ट्रेंथ. डायलेक्ट्रिक स्ट्रेंथ का मतलब क्या हुआ? डायलेक्ट्रिक का मतलब क्या है? इंसुलेटर. So dielectric strength means a strength up to which it will stay insulator. ठीक है. क्योंकि तुम कब तक मजबूत रह सकते हो? हाउ लॉन्गर यू कैन फेस डिफिकल्टीज. देर इज लिमिटिंग पॉइंट फॉर एवरीबडी, है ना. देर विल बी अ मोमेंट व्हेन यू विल ब्रेक. We all have certain limit up to which we can take pressure, tension, everything. After that, we will simply break, we will collapse. Similarly, here also, in this dielectric, there is electric field. If electric field is getting stronger, up to certain limit only, this dielectric can sustain the electric field. Sustain the electric field का मतलब certain limit तक ही electric field को बढ़ा सकते हो, such that dielectric will remain dielectric. ठीक है. सो अगर तुम एयर की बात करो तो तुम्हारे एनसीईआरटी में भी दिया हुआ है 3 into 10 to the power 6 volt per meter. Volt per meter is the unit of electric field. If electric field reaches up to this strength, then air will no longer remain dielectric. It will break. ठीक है. It will collapse. So after that, it will be a conductor. And why this collapse is happening? We can explain this collapse very easily. Let's now discuss this. Air क्या है तुम्हारा? Air is an insulator, but it has atoms, gaseous atoms. Let's focus on single atom. Let's say there is one atom and there is one electron here. Maybe there will be so many electrons in its outermost cell. लेकिन मैंने सिर्फ एक इलेक्ट्रॉन पे फोकस किया है. Let's talk about this thing. Capacitor will store which sort of energy? You are storing charge on the capacitor. Somebody asked me what sort of energy we are storing on the capacitor. So to the capacitor, you are giving charge, and this charge is generating electric field. So basically, we are storing electrostatic energy. On the capacitor, we will store what form of energy? Electrostatic energy. That we will discuss later also more. What will be the value of energy? What things will be there? We will discuss. Okay. For now, let us understand this dielectric strength. So, if electric field reaches to the value 3 into 10 to the power 6 voltmeter, then what will happen? Dielectric will break. Means dielectric will become conductor. How it can become conductor? Conductor means something that has free mobile charges. Okay. So let's talk about single atom of the air. Electric field is there. Since this, it has a positive charge, right? So if this positive charge is quite stronger, so strong that it is able to pull this outermost electron out of the atom, then this atom will get ionized. And if this atom get ionized, what will happen? There will be electron and positively charged atom in the air. So free mobile charges will start getting generated. And if these free electrons are there, electron will get attracted to the positive plate, and this positive atom will get attracted to the negative plate. So with time, what will happen? Positive plate will start losing its positivity because electron is getting accumulated on this surface. So positivity of positive plate will decrease, negativity of negative plate will decrease. Overall, you can say charge on capacitor starts leaking. And then there will be a time when this plate will become neutral, and also this will become neutral. Okay? Because this media, which was initially air, insulator, is now conductor. Because its dielectric has broken. Okay? So every dielectric has dielectric strength. Means it can remain dielectric up to certain value of electric field. Okay? And certain value of electric field कहने का मतलब who is generating the electric field? Charge on the plate. So you cannot store infinite amount of charge on any sort of capacitor. There is limit to it because there is limit to the dielectric strength. ठीक है? चलो. So this is यहाँ पे हमें क्या क्या चीजें मिली सीखने को? One thing is your leaking of capacitor. Leaking of capacitor terms बहुत जगह मिलेगा बाद में. अच्छे questions करोगे, you will get to know. So what is this leaking of capacitor? It happens because dielectric breaks. And when dielectric breaks, we get three mobile charges, that is positive and negative both. Positive plate will start losing its charge because of accumulation of negative charge on its surface. And similarly, similar thing will happen with what? Negative plate. Okay? And capacitor will leak. Done? And finally, capacitor will become neutral. Means we won't be able to store charge on the capacitor. That is called leaking of capacitor. We understood one more thing, that is called dielectric strength. ठीक है? So air का dielectric strength कितना होता है? That is 3 into 10 to the power 6 volt per meter. ठीक है? Kiran, that is a different game actually. In lightning, what happens? Separation of charge occurs, and because of potential difference getting created, suddenly a large amount of current flows, and that is the reason of lightning. Okay, it's not because of this thing. ठीक है, but you can indirectly say, how you can say, क्योंकि देखो मैंने बोला ना large क्या separation हुआ, चार्ज का सेपरेशन हो गया. सो लार्ज चार्ज का सेपरेशन कहने का मतलब in this atmosphere there is what? Strong electric field getting generated. So intervening media, which is air, will become conductor and current will flow. Strong amount of current will flow. So yes, you can say that way. ठीक है? Done है, Kiran?
Madam, shall you repeat leaking of capacitor again?
Okay. सो लिकिंग ऑफ कैपेसिटर में मैंने ये बोला ना कि जैसे देखो ध्यान से, देखो मैं बताती हूँ, लिक करने का मतलब क्या होता है। जैसे कंटेनर में पानी रखे हो, लिक कर रहा है, मीन्स पानी घटेगा, है ना। सो यू हैव टू कैपेसिटर्स हियर। इस पे सपोज कर लो मैंने प्लस क्यू चार्ज दिया था, इस पे माइनस क्यू दिया, ठीक है। एंड इस चार्ज की वजह से इस रीजन में इलेक्ट्रिक फील्ड है। नेक्स्ट से इलेक्ट्रिक फील्ड ये इतना ज्यादा स्ट्रांग हो गया है, इट इज गोइंग टू ब्रेक द डायलेक्ट्रिक। ब्रेकिंग द डायलेक्ट्रिक मीन्स इंसुलेटर। सो इफ इंसुलेटर इज गेटिंग ब्रोकन डाउन, इट मीन्स इट इज बिकमिंग कंडक्टर, ठीक है। सो यहाँ पे फ्री चार्जेस हो जाएंगे, फ्री पॉजिटिव नेगेटिव चार्ज। So negative charge will get attracted towards positive plate. Positive charge will get attracted towards negative plate. So gradually plus Q charge wala jo plate hai, that will receive negative charge. It means its positivity will decrease, and also similarly its negativity will decrease. So overall after certain time you will see here charge is small q and here charge is minus q, which is less than capital Q. So charge is leaking, and after certain amount of time this will almost become what, 0 0. So all charge it has lost. Why? Because uh, this dielectric got broken down, it became conductor. So basically it समझ रहे हो ना, अगर कंडक्टर बन गया, वी विल हैव सो मेनी मोबाइल चार्जेस, नेगेटिव विल गेट अट्रैक्टेड टुवर्ड्स पॉजिटिव प्लेट, पॉजिटिव विल गेट अट्रैक्टेड टुवर्ड्स नेगेटिव चार्ज, ठीक है। इज इट क्लियर? ओके, चलो किरण, थैंक यू। वर्मा, यू अंडरस्टूड?
Yes,
यू आस्क्ड मी
madam.
दिस राइट, आई गेस। ओके, थैंक यू। चलो ठीक है, लेट्स नाउ डू दिस थिंग। नाउ वी विल लर्न कैपेसिटेंस, ठीक है। सो who is sending this recording idea? I mean, it's already going live on YouTube, so it's there stored. No need to record it. A spherical capacitor. Now we will calculate capacitance, ठीक है। So सबसे पहले हम देखते हैं कि capacitance का फॉर्मूला क्या लिखे, कैसे निकाल सकते हैं capacitance. So capacitance will plainly depend on two things. One is geometry, and another is your media. मीडिया पे कैपेसिटेंस डिपेंड कर रहा है। अभी अभी हमने देखा मीडिया का डायलेक्ट्रिक स्ट्रेंथ जितना स्ट्रांग होगा, that amount of charge or more amount of charge we will be able to store. If media has low dielectric strength, it means we will be able to store less amount of charge. So definitely capacity of conductor will depend on what is the media in between the plates. So it will depend on media, and second is geometry. ज्योमेट्री पे भी डिपेंड करेगा कि तुम्हारा उसका कैपेसिटी क्या है। वी विल सी लेटर ज्योमेट्री पे कैसे कैसे डिपेंड कर रहा है, ठीक है। एंड इफ यू विल सी हियर, जैसे यहाँ पे मैंने बोला क्यू amount of charge that you were storing on the capacitor is somehow depending on the dielectric strength, and dielectric strength will get broken down by the electric field present between the plates, ठीक है। and electric field अगर इस region में E है, let's talk about the capacitor. It has a plus Q charge, it has a minus Q charge. Let's say here electric field is E. So far we have not calculated the value, so let's say it is E. And if this distance is d, then what will be the potential difference between the plates? This is a positive plate, है ना? It will have positive potential. You already know, because of positive charge we get positive potential. This is a negative plate. It has negative potential. So positive plate is at higher potential, negative plate is at lower potential, and hence there is potential difference between the plates. Done it? And here if you calculate potential difference, it is V plus minus V minus, है ना, plates का potential difference. Can we write it in terms of electric field also? Yes, because we have learned the formula dv equal to minus E dot dr. पढ़ा है ना हमने ये formula. So if you look at here, if you talk about the magnitude of potential difference, simply this separation is d, and electric field in this region is E. Let's say E is a constant, then potential difference dv will be equal to E into d. We can write here. Done it? समझ रहे हो? डिस्प्लेसमेंट आई एम सिंपली टेकिंग इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड. मैं डीवी का मैग्नीट्यूड निकाल रही हूँ, सो आई एम टेकिंग मॉड्यूलस सिंपली. सो इफ इलेक्ट्रिक फील्ड इज कांस्टेंट इन द रीजन and two points are separated by a distance d, then we can say potential difference is what? AD. Then, so if you look at here carefully, potential difference is also depending on the electric field. Done it? And electric field is deciding how much amount of charge you will be able to store to the maximum. Done it? So Q is somewhat function of electric field, you can say. And electric field is also, potential is also the function of electric field. So overall Q charge, which we are storing on the capacitor, is also function of potential. Okay? Because E and B are related. dV equal to what? E into D. तो पोटेंशियल डिफरेंस पे डिपेंड करेगा चार्ज कितना हमने स्टोर किया है. इसलिए यहाँ पे एक जनरल स्टेटमेंट है, Q इज डायरेक्टली प्रोपोर्शनल टू V. Here is what? V here is V plus minus V minus. So basically V is the potential difference. And charge getting stored on the capacitor is directly proportional to potential difference. This is the observation. This we have got experimentally. This we have got after seeing what is happening on the capacitor. So this is experimental observation, and we can clearly see here mathematically also somehow, right? Because charge started leaking because of high value of electric field. So somewhat charge getting stored on the capacitor is the function of electric field, and hence the potential difference. And hence we are writing here Q is directly proportional to V. And here proportionality constant is written as C, which is the capacitance. ठीक है? तो कैपेसिटेंस ऐसे देखने से लग रहा है कैपेसिटेंस इज Q by V, but capacitance is actually not function of charge and voltage difference. Capacitance is function of geometry and medium. That you should be clear of. Oh, tomorrow there will be class. Tomorrow is Friday or tomorrow is Saturday or what? Sunday. देखो मैं दिन भूल जाती हूँ, आज Friday. So if today is Friday, then tomorrow is Saturday. Why there won't be class? Is there any फेस्टिवल और समथिंग? क्यों पूछ रहे हो, बताओ ऑल ऑफ सडन. यस, चलो ठीक है, बता देना क्यों पूछ रहे थे. if you want to then. Okay, C equal to Q by V. So don't get confused कि capacitance is function of charge and voltage. By the equation it looks like, but experimentally we have seen it doesn't depend on charge and V. Capacitance depend on geometry and media. So अगर question आता है capacitance depends on what, you will say geometry and media. Done it? Chalo. Now we will learn a spherical capacitor. So how we generate a spherical capacitor first. पैरेलल प्लेट कैपेसिटर हमने देखा. स्फेरिकल कैपेसिटर में क्या होगा? वी विल हैव टू कंसेंट्रिक स्फीयर. लेट्स से वन इज ए एंड अनदर इज व्हाट? अनदर इज ऑफ रेडियस बी. नाउ लेट्स से वी आर गिविंग चार्ज Q टू द स्मॉलर स्फीयर. सो इसको मैंने Q चार्ज दिया. नाउ since both are conductor, this Q charge will generate electric field in this region. This is again this region is getting occupied by air or something, dielectric. This is a hollow sphere sort of thing. Okay, so this is this. If Q charge we will give to the inner sphere, negative charge will get attracted here like this. ठीक है, होगा क्योंकि कंडक्टर है. आउटर स्फीयर भी क्या है? कंडक्टर है, इसके पास फ्री चार्जेज होंगे, and its positive charge will go on the outer region. Its positive charge will go on the outer region, same amount of positive charge. And since we have not to retain the positive charge here, simply we will earth it. Okay, so positive will go here, and then we will have capacitor looking like this. It will have a positive charge and it will have a negative charge throughout the surface. Okay, like this. Sorry, ऊपर बना रही हूं मैं नेगेटिव इनसाइड. ठीक है. So again, this is a spherical plate capacitor or a spherical capacitor. One of radius A, another of radius B, and both are concentric spheres. Now we will calculate its what? Capacitance. How we can do this? बताओ. अभी अभी हमने देखा Q is equal to क्या है? CV है ना? और v तुम्हारा क्या होता है, दोनों प्लेट के बीच का पोटेंशियल डिफरेंस. q इज व्हाट, अमाउंट ऑफ चार्ज यू आर गिविंग. लेट्स से वी आर गिविंग इनर प्लेट प्लस q चार्ज एंड दिस आउटर प्लेट हैज अ चार्ज ऑफ माइनस q. So q value is already given. Somehow, if we are able to calculate what is potential difference between these two plates, then we can easily calculate what? Then we can easily calculate which thing? बताओ, बोलो. Capacitance. अब तुम लोग इलेक्ट्रोस्टैट के नॉलेज को यूज करो. व्हाट विल बी द पोटेंशियल ऑफ दिस इनर स्फीयर, मुझे जल्दी से बताओ क्या होगा. इस इनर स्फीयर का पोटेंशियल क्या होने वाला है. I have taught you all the formulas. I told you if there is a spherical hollow sphere and you are giving charge q on it, then potential on the surface will be kq by r, and also potential at any point inside will be same as potential on the outside charge. Sorry, at the surface. Yes, Lakshmi, thank you. So that will be this. अब चलो एक काम करते हैं, हम हमारा एक टास्क है, तुम लोग सभी करो. ठीक है. यस लक्ष्मी, तुम लोग सभी करो, एक काम करो, स्मॉलर स्फीयर का पोटेंशियल निकालो. पोटेंशियल ऑफ स्मॉलर स्फीयर कितना होगा बताओ, क्या लिखूं. सभी लोग सोचो और करो. व्हाट शुड बी राइट. सब लिख लिए. सो स्मॉलर स्फीयर पहले तो प्लस क्यू चार्ज की वजह से पोटेंशियल होगा. स्मॉलर स्फीयर के सरफेस पे लिख रही हूं मैं पोटेंशियल, तो के क्यू बाई ए. और एक चीज और ध्यान से देखो, देर इज ऑल्सो नेगेटिव चार्ज ऑन द इनर स्फीयर, एंड दिस पॉइंट, एनी पॉइंट ऑफ द स्मॉलर स्फीयर surface is inside this bigger sphere. So at this point, if I talk about potential will be because of charge on the smaller sphere and also because of charge on the outer sphere. So potential at the surface of outer sphere will be how much? Minus kq by a. ठीक है. And what will be yes, Kiran. What will be potential at any inside point of this sphere because of charge on the bigger one? It will be kq by a only. ठीक है. सो स्मॉलर स्फीयर का टोटल पोटेंशियल अगर आप लिखते हो तो क्या लिखोगे, माइनस के क्यू बाई हाउ मच, बी. सॉरी ए नहीं, बी होगा, ये उसका रेडियस बी है ना. सो माइनस के क्यू बाई बी. दिस इज द पोटेंशियल ऑफ स्मॉलर स्फीयर. एवरीवन एग्री विद दिस? Because the smaller sphere is inside the bigger sphere. So potential at the surface of inner sphere will be because of two charge. One because of charge on itself, kq by a, and another because of charge on the bigger sphere. Okay, and that will be equal to minus kq by b. Now what will be potential of the larger sphere? Batao. Because of this positive charge, I mean, if you take any point on the bigger sphere, this point will be, let's say this is point P. This point P will be an outside point for the smaller sphere. So for a smaller sphere, because of charge on the smaller sphere, potential at point P is how much? kq by b. Why I'm taking b? Because this is an outside point at a distance b. So potential kq by b. Now what will be the potential at the surface because of this negative charge? That is minus kq by b. ठीक है. And if you now take the difference of these two two potentials, Vs minus Vl, because ultimately the plate that is having positive charge will have, you can say, higher potential. ठीक है. So Vs minus Vl मैं कर रही हूँ. If you will subtract these two, you can clearly see these two things will get cancelled. Which one? This and this. So this thing will get cancelled. KQ को common ले लो. 1 by A minus 1 by B. This is going to be the potential difference. So you can write here KQ B minus A by AB. ठीक है. This way we can write. अब आप C निकाल लो. C equal to what? Q by V लिखो यहाँ पे. Q value is Q and V is potential difference. It is equal to KQ B minus A into AB. Q को आप कैंसिल कर दो. AB के को आप लिख डालो. के क्या होता है, 1/4 पाई एप्सिलॉन नॉट. सो दिस इज 4 पाई एप्सिलॉन नॉट ए बी बाई बी माइनस ए. ठीक है. So this will be the capacitance of this spherical capacitor. Done. अब देखो, इसको दूसरे मेथड से भी हम कर सकते थे. कैसे? जनरल फॉर्मूला यूज भी कर सकते थे. वी कुड हैव डन इंटीग्रेशन आल्सो. लेट्स से एट दिस पॉइंट, at any inside point you calculate the electric field. So at any inside point, I mean inside point means point inside the capacitor that is in this region. If you take any point in this region, then electric field here will be only because of the smaller sphere. क्यों? क्योंकि outer sphere तो conducting है, and because of charge on its surface, and also it is hollow. We already know for hollow sphere having charge q on its surface, electric field inside is zero. So if you write electric field, okay, चलो ठीक है, पहले बैक स्लाइड में चलती हूँ. ओके, टेक योर 1 minute ऑफ टाइम टू गो थ्रू इट. ठीक है. जब हो जाए तो तुम बता देना. ठीक है.
ओके मैम.
ओके, थैंक यू. तो यहाँ पे और कैसे कर सकते थे मैं वो बता रही थी. ठीक है. सो इस इनसाइड स्पेस में कोई भी एक पॉइंट पे इलेक्ट्रिक फील्ड का वैल्यू लिखो. कितना होगा इलेक्ट्रिक फील्ड का वैल्यू? KQ/R² होगा. वाई? बिकॉज बिगर स्फीयर पे जो नेगेटिव चार्ज है उसकी वजह से इलेक्ट्रिक फील्ड कैन नॉट बी इनसाइड. Then we already know for hollow sphere having charge q or minus q on its surface, there won't be electric field at any inside point. It will be zero always. Okay. So this is this. Now we can use the formula dv equal to minus E dot dr. So if you use this, how you can use this formula? Let's say potential of this surface is Vs and potential of this surface is Vl. Okay. We are moving in this direction. Electric field will also be in this direction. So E or dr, we are moving from smaller to the larger plate for dv calculation. Then minus E dr cos 0 लिखोगे because displacement I am taking in the direction of electric field. So this will become how much? Minus E dr cos 0, that is 1. And this is dv. अब क्या करो? dv को ऐसे लिखो, E का वैल्यू लिखो minus KQ/R². At any distance R I am calculating. At any distance R here. ठीक है, इस पॉइंट पे KQ/R², and then we are moving a bit further away, dr distance towards the negative plate dr, and then we will check what is the difference. And this R for calculating potential difference, I mean across the dr length, across this dr length, if we are calculating potential difference, then that is equal to E dot dr. But we have to calculate potential difference across this width. यानी कि for this width calculation, R value will vary from A to, because this width is starting from here to here, means R will vary from A to B. So here R will vary from A to B. And at A, if let's say potential is Vs, and at B, let's say potential is VL. So we needed to calculate Vs minus VL. यहाँ पे VL minus Vs आएगा. Then you will take the sign properly. ठीक है. So you can easily solve this thing also. यहाँ पे VL minus Vs तुम्हारा क्या आ जाएगा? KQ को कॉमन ले लो नेगेटिव साइन के साथ, -1/R A to B. ठीक है. You will solve, you get the same result. ठीक है. So this way also we can do. Now we will deal with parallel plate capacitor, which we have to study largely. Everywhere you will get parallel plate capacitor. So in parallel plate capacitor, what things we are having? We are having two seats. ठीक है. So this is seat 1, this is another seat. One is given plus Q charge, another is given minus Q charge. This plus Q and minus Q charges are basically distributed on the inner surfaces of both the plates. ठीक है. So on the facing surfaces, charges are there. ठीक है. Now how we will calculate capacitance of this parallel plate capacitor? So Q equal to हम जानते हैं CV. So somehow if we are able to calculate the potential difference, we will be able to calculate capacity. ठीक है. We will do it one by one. So इससे पहले मैं ये बता दूं, यहाँ पे जो भी हम कैपेसिटर पढ़ेंगे ना, and whatever parallel plates we are taking, those plates are assumed to be of larger size, so that we can use the formula of electric field because of planar seat, infinite planar seat. हमने फॉर्मूला पढ़ा था ना, if we have a seat, है ना, seat like this, if it is infinitely long seat, right? Then electric field at any point in front was sigma by epsilon naught for conductor and sigma by 2 epsilon naught for non-conducting. ठीक है? So जब भी हम parallel plate पढ़ते हैं, we assume seats are larger so that we can utilize this formula. Done it? We will be using these approximations. This is your homework. You have to calculate capacitance of cylindrical capacitor. So there are two plates here. One inner cylinder, another one outer cylinder. Both are coaxial cylinder. You have to calculate it. See. तो तुम लोग इसके अराउंड थोड़ा सोचना. अब चलो, अब हम लोग डिस्कस करेंगे पैरेलल प्लेट्स को, और ये बहुत ही इजी होने वाला है, एक्सट्रीमली इजी. इलेक्ट्रिक फील्ड को पहले डिस्कस करते हैं. मैंने तुम लोगों को क्या बोला, पैरेलल प्लेट्स के फेसिंग सर्फेसेस पे चार्ज होंगे. तो इनर सर्फेस की मैं बात कर रही हूँ. लेट्स से इट हैज अ पॉजिटिव चार्ज, इट हैज अ नेगेटिव चार्ज लाइक दिस. नाउ वी एम टू कैलकुलेट इलेक्ट्रिक फील्ड. Again, just now I told you in parallel plate, we will assume seats are larger so that we can use the formula. Now let's focus on this seat. Let's take a point here, point 1. And at point 1, let's calculate electric field because of both the plates. Then only we will get total electric field at point 1, because that electric field will be because of positive plate and negative plate. अब देखो, अब ध्यान से सोचो. यहाँ पे मैंने तुम्हें क्या बोला, जब मैं इलेक्ट्रोस्टैट में स्पीड पढ़ा रही थी, आई टोल्ड यू वन इज कंडक्टिंग, अनदर इज नॉन कंडक्टिंग. आई ऑल्सो टोल्ड यू व्हाट इज द मीनिंग ऑफ कंडक्टिंग सीट. कंडक्टिंग सीट का मीनिंग सिर्फ कंडक्टर होने से नहीं है. कंडक्टिंग सीट का मीनिंग था कि उस सीट के दोनों सर्फेसेस पे चार्ज होंगे, बोला था मैंने. और नॉन कंडक्टिंग का मतलब सिंगल सर्फेस पे चार्ज होगा. सो दो दिस प्लेट इज अ कंडक्टर, दिस प्लेट इज व्हाट, कंडक्टर, but we have only maintained charge on one surface. So, though it is a conductor, it is behaving like non-conducting sheet. So, at one point, if we have to write the electric field because of positive plate, we will write the formula as, because of positive plate, electric field will be equal to how much? Sigma by 2 epsilon naught. I'm not taking sigma by epsilon naught, though this is a conducting sheet. Why? Because charge distribution is not like conducting. It's simply on one surface. Done है? और चार्ज डिस्ट्रीब्यूशन की वजह से ही एक सिग्मा बाई एप्सिलन नॉट आया था और दूसरा सिग्मा बाई 2 एप्सिलन नॉट आया था, इफ यू रिमेंबर. एग्जैक्टली. आई हैव टेकन गॉसियन सरफेस, आई हैव शोन यू कि कैसे कैसे डिफरेंसेस आएंगे. So here it will it is charge distribution seems like non-conducting. That is why I use the formula this. So at point P, electric field is in this direction because of plus Q charge. Because of negative charge, what will be the electric field at point 1? So it will be in this direction, electric field, because of negative charge. Because of negative charge, electric field has to end. So electric field is in this sense. Now electric field, because of negative charge, magnitude will be same, and direction is also same here, you can see. So at one point, net electric field is what? Net electric field is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So sigma by epsilon. What is this sigma? Sigma, if you remember, it was your charge stored, charge per unit area. So if this plate of capacitor has an area A and it has charge plus Q, then sigma is equal to Q by A. क्लियर है? चलो, अब देखो, अगर तुमसे कोई पूछता है कि कैपेसिटर के प्लेट के बाहर के पॉइंट्स पे इलेक्ट्रिक फील्ड बताओ, लेट्स से एट पॉइंट 2 आई एम आस्किंग इलेक्ट्रिक फील्ड. So again, you will, I mean, for C, electric field formula is sigma by 2 epsilon naught here, done it? And this formula is not depending on the distance. So at point 2, because of positive charge, electric field will be in this direction, value sigma by 2 epsilon naught. And at point 2, electric field because of negative charge will be in this sense, directed inward on the plate, right? So these two are oppositely directed, equal in magnitude. Electric field will be 0. Here also electric field will be 0. So if you are having two parallel plate capacitor outside the plates area, electric field is what? 0 in the region. Inside the plate, electric field is how much? Sigma by epsilon naught. Clear है? किसी को doubt है यहाँ तक? If yes, you can let me know. किसी को डाउट है? एनीबडी? नो? चलो
No,
ठीक
no.
है. ओके ओके, थैंक यू. नाउ वी विल कैलकुलेट पोटेंशियल डिफरेंस. अभी अभी मैंने बताया इलेक्ट्रिक फील्ड अगर हमें पता है एंड लेट्स से दिस इज पॉजिटिव चार्ज, दिस हियर देयर इज नेगेटिव चार्ज एंड डिस्टेंस बिटवीन प्लेट्स इज d, then potential difference that is getting indicated by v will be equal to E into d. सिंपल, पहले भी एक्सप्लेन किया मैंने. सो ई इलेक्ट्रिक फील्ड को आप क्या लिखोगे? इलेक्ट्रिक फील्ड को लिखोगे सिग्मा बाई एप्सिलॉन नॉट इनटू डी. आ गया? दिस विल बी द वैल्यू. ठीक है. सो v इक्वल टू ई डी, ये काफी इंपॉर्टेंट है. If d is along the direction of electric field, here d is this, electric field is this, so v will be equal to E into d, and here E is constant throughout, so directly constant value we can keep, d we can keep, and then we can get potential difference. ठीक है. अब देखो कैपेसिटेंस निकालना है, अभी इसमें निकल जाएगा. Q इक्वल टू क्या होता है? CV. सो Q का वैल्यू Q रहने दो, C हमें नहीं पता, V हमें पता है, सिग्मा बाई एप्सिलॉन नॉट इनटू D. अब आप इसको ब्रेक कर लो, C बाई एप्सिलॉन नॉट D इनटू सिग्मा को क्या लिखोगे? Q बाई A. Let's say this has plus Q charge, this has minus Q charge, area is A, and this distance is what? D. Then we can write like this, okay? Q will get cancelled, and C is equal to epsilon naught A by D. Now look at the formula. This formula is depending on geometry and on media. Media is getting indicated by this epsilon naught term. If it is now not vacuum or something, then epsilon will be there. So C is depending on the media and on the area of plate, distance between plates. So on two factors it is depending. One is your geometry and another is your media. Okay? So these were the formulas. Now we need to calculate force between plates. What will be force between plates? So here there is a positive charge. Here there is a negative charge. So it's like we are going to calculate force due to plus Q on minus Q. It is same as this, right? So it's like we are going to calculate what force this positive plate is acting on the negative plate. So force को either point charges के लिए हम force को क्या लिखते थे? Q1 Q2 by R से. But these are not point charges, right? Charge is on a plate, another charge is also on the plate distributed. तो फोर्स को हम एक और फॉर्म में लिखते हैं, दैट इज Q इंटू इलेक्ट्रिक फील्ड. लिखते हैं ना, Q इंटू E. सो हियर इफ यू सी, if we are going to calculate force on negative plate because of positive plate, what will be the value? So then we need to check what is the electric field because of positive plate. Done. फोर्स अगर निकालना है on negative plate because of positive plate, then we will use the formula Q into E. Which electric field we will be taking? The electric field that positive charge is generating. So that was equal to sigma by 2 epsilon naught into charge on negative plate. साइन के साथ साइन को हटाकर लिखूं तो Q. So this will be the force. Electric field का formula we cannot keep sigma by epsilon naught because it will be wrong, because sigma by epsilon naught is the aggregate value of electric field. It is because of both the plates. But here we are calculating force on another plate because of one plate. So we need to see what electric field is getting generated by one plate, not by both plates. ठीक है? That way we will calculate force. और यहाँ पे अगर इसको break करो sigma को, तो Q square by 2A epsilon naught. This is the force between plates. Yes. Any doubt, anybody? If you have, you can let me know. No? Chalo, ठीक है. Now we will see energy stored in the capacitor. What is the energy stored in the capacitor? ठीक है. So we have capacitor at a separation D. है ना? Let's say initially these two plates were just at a dr separation. Done it? And then we need to, this has a positive charge, this has a negative charge. Done? And they are at a very small separation initially. And we need to enlarge this separation to small d. so that we can get a capacitor like this. So for this we will do some work, क्योंकि ऐसे भी देखो ये पॉजिटिव प्लेट नेगेटिव को अट्रैक्ट कर रहा है. So if we have to take it away, we need to do work, right? So what will be the work done here? Work done क्या होगा बताओ. Initially, let's say separation between them is nothing, almost nothing. So work done will be force acting on negative plate into distance, by whatever distance you are moving it. So force acting on negative plate is how much? Q square by 2a epsilon naught into d. यही होगा वर्क डन, राइट? तो यहां से अगर आप लिखो तो Q स्क्वेयर बाई 2 इंटू एप्सिलन नॉट ए, इस d को नीचे लेकर आ जाओ लाइक दिस, एंड एप्सिलन नॉट ए बाई डी इज t, राइट? So work done is Q square by t 2c. And whatever work we are doing in assembling this capacitor, which is two plates at a separation d, this work then will get stored in the form of electrostatic energy. That is, there is electric field in this region, and in this electric field, whatever work we have done will get stored. ठीक है? So energy को और कैसे लिख सकते हैं? इसको वोल्टेज के फॉर्म में भी लिख सकते हैं. जैसे देखो Q को क्या लिख दो? CV लिख दो. So CV का स्क्वायर 2C. So this will become half CV square. So energy stored on the capacitor can be written in two forms. What are those? Energy stored on capacitor का formula half CV square या फिर Q square by 2C. So how we got this energy? You saw here, if plates are at zero separation, there is no capacitor. If you want it to be at a separation D, we need to do work, because one is having positive charge, another is having negative charge. To separate it, we need to do some work, and that work will get stored in the form of electrostatic energy, potential energy. Okay? So energy is getting stored in this field. Now we can calculate one more famous thing, or बहुत ही common thing, that is, what is the energy stored per unit volume? If you talk about this capacitor, then this capacitor is like one plate is this phone. If you look at this phone, this is one plate. Another such identical plate is here, and in between these two plates there is a volume. Done it? So overall, if you talk about capacitor, this whole is the capacitor region. So how much energy is getting stored per unit volume? Area of the capacitor is A. This distance is D. So volume getting occupied is how much? A into D, right? So energy per unit volume की अगर बात करो तो कितना होगा बताओ? Energy total कितना हमने लिखा? Q square by, या फिर CV square से ही चलते हैं. चलो यहाँ पे लिखो CV square by 2. और ये मैंने लिखा है वॉल्यूम, इसको वोल्टेज से कंफ्यूज नहीं करना है. एनर्जी स्टोर पर यूनिट वॉल्यूम, एंड दिस इज एनर्जी. वॉल्यूम कितना है बताओ? A इंटू टी. दिस इज द वॉल्यूम. अब चलो एक काम करते हैं, इसको और भी ब्रेक करके लिखते हैं. C को लिख डालो एप्सिलॉन नॉट A बाई D. ठीक है? जस्ट बिकॉज वी वांट टू रीच एट सर्टेन फॉर्मूला, इसलिए मैं ब्रेक कर रही हूँ. 2D इंटू A, यहाँ ऐसा है एप्सिलॉन नॉट A बाई D लिखा, और पहले से यहाँ पे D था, है ना? एप्सिलॉन नॉट A बाई D, C को ब्रेक किया, AD था पहले से, एंड दिस इज योर V का स्क्वायर. नाउ यू कैन सी हियर A विल गेट कैंसिल्ड, एंड हाफ एप्सिलॉन नॉट V बाई D का स्क्वायर. एंड इफ यू रिमेंबर, V किसके बराबर था? ED. V बाई D विल बी इक्वल टू व्हाट? E. So here it is equal to half epsilon naught E square. Now let's look at it again. यहाँ पे क्या मैंने बोला? एनर्जी स्टोर्ड पर यूनिट वॉल्यूम. वॉल्यूम की बात करी मैंने, और वॉल्यूम में है क्या? अगर तुम सरफेस, चार्ज सरफेस पे है, वॉल्यूम में क्या है? इलेक्ट्रिक फील्ड. सो बेसिकली वी आर टॉकिंग अबाउट हाउ मच एनर्जी पर यूनिट वॉल्यूम एग्जिस्ट इन सर्टेन इलेक्ट्रिक फील्ड रीजन. सो कभी कभी तुमसे ये पूछता है कि there is random some electric field, let's say electric field is E, then what is the energy stored per unit volume? You will simply say half epsilon naught E square. ठीक है? So this is this. अब तुम्हें कैपेसिटर थोड़ा और समझ में आया होगा. कैपेसिटर क्या है? सिस्टम ऑफ टू प्लेट, वन विल हैव पॉजिटिव चार्ज. सॉरी, कैपेसिटर सिस्टम ऑफ टू प्लेट्स. व्हाट इज द फंक्शन? टू स्टोर चार्ज और टू स्टोर इलेक्ट्रोस्टैटिक एनर्जी. यहाँ पे चार्ज दिया तो हमने एक वॉल्यूम जनरेट किया where there is electric field, and that region is storing energy in it, right? And that energy per unit volume is half epsilon naught A square. So if you get asked like for parallel plates, let's revise things. What is the electric field between the plates of capacitor? Sigma by epsilon naught. Outside it's zero always. What is potential difference? ED, that is sigma by epsilon naught into D. What is capacitance? Epsilon naught A by D, not depending on Q and V, only on geometry and media. After that, we learned what is the force between plates, Q square by 2A epsilon naught. And then we studied how much energy is stored in the capacitor. Done it? And that is half CV square or Q square by 2C. Done it? Or another language में तुमसे पूछ सकता है what is the energy stored per unit volume in the electric field. So that is half epsilon naught E square. So I hope it is clear. किसी को डाउट है यहाँ तक तो बताओ. Anyone, if you are facing doubt, you can let me know. कल के क्लास में हम क्या पढ़ेंगे? Combination of capacitors पढ़ेंगे. ठीक है? Series parallel combination पढ़ेंगे. So one class I will dedicate to that, and after that again more conceptual thing will start. That is your dialectic. डायलेक्ट्रिक को हम लोग डिटेल में पढ़ेंगे. जिस तरह से हमने पढ़ा था ना कि कंडक्टर को इलेक्ट्रिक फील्ड में रखते हैं तो क्या होता है, हमने पढ़ा था, उसी तरह से हम पढ़ेंगे कि डायलेक्ट्रिक को इलेक्ट्रिक फील्ड में रखते हैं तो क्या होगा. क्यों पढ़ना जरूरी है? क्योंकि देखो कैपेसिटर के प्लेट के बीच में क्या था? डायलेक्ट्रिक. एंड कैपेसिटर के प्लेट के बीच में क्या है? इलेक्ट्रिक फील्ड. सो बेसिकली डायलेक्ट्रिक इज इन इलेक्ट्रिक फील्ड. व्हाट विल बी द इफेक्ट दैट वी विल लर्न. ठीक है? But कल के क्लास में we are going to learn series parallel combination of capacitor. Anyone having any doubt? No one? Kalarsan, you got it? Mahesh, Latika, Nishmita, Priya, Ranju, Rimbina, Tejashwini, Lakshmi, Kiran, Tanush. किसी को कोई डाउट नहीं है? Everyone okay with this? One Verma, you used to ask doubts actually, so I need to ask with you, है ना? Okay, ठीक है, thank you. भूमिका, जिरमिली, कार्तिक. चलो सबके नाम ले रही हूँ सो दैट याद कर सको तुम लोगों को. चलो ठीक है. इफ देर इज नो डाउट देन वी आर गुड टू गो. हैव योर टाइम. टेक टी ब्रेक, वॉट एवर ब्रेक इज देयर. इफ यू आर इन स्कूल देन या गो फॉर प्ले टाइम इज ओवर ऑलमोस्ट आई वुड से. बट थैंक यू फॉर स्टेइंग टिल द लास्ट. चलो नाउ यू कैन लीव. एंजॉय योर टाइम. बाय एवरीवन. टेक केयर. थैंक यू. बाय बाय. किरण बाय बाय. कलासन टी